Hi, my name is Kinsley Ray. Today I'll be explaining Concept Challenge 9.1, which is the control of muscle tension. For the first figure, I'll be explaining motor units and recruitment. So a motor unit is just one motor neuron plus all of the muscle fibers that it stimulates. So in this case, motor unit 1 is blue, and then motor unit 2 is green. So in the figure, motor unit 1 can only stimulate 2 muscle fibers, whereas motor unit 2 can stimulate 3 muscle fibers. So a motor unit sends a signal from the neuron, which is in the spinal cord, to the specific, and then it travels through the axon to the specific muscle in the body that you're trying to use, and then it goes to the specific muscle fibers for that motor unit. So, depending on what activity you're doing and how much force you need, the body determines which and how many motor units to recruit. For example, if you're lifting a cup of juice, you might only need to recruit motor unit 1, but to lift a carton of juice or a gallon of juice, you need to stimulate motor units 1 and 2, or all the motor units in that muscle. You recruit more motor units based on the amount of force you need. So obviously a carton of juice is larger than a cup of juice, so you're going to need more muscle fibers to lift the carton of juice. On to figure 2, I will explain sustained muscle contraction, which is also called tetanus. Skeletal muscle contraction is a graded activity, meaning you control how much your muscles contract and how much strength you use during a movement. And this is controlled by the number of action potentials that goes to a muscle fiber, which also changes the muscle tension, as you can see in the graph. So right here, a single action potential produces a single twitch, which produces a small amount of tension. However, when there are 2 or more action potentials closely spaced together, they add to each other because the muscle doesn't have enough time to relax in between each action potential. So as you can see, summation of 2 twitches, sum in math means to add, so you can just think about how they would add to each other, so the tension is higher than a single twitch. As you can see in the last one, when there's a series of action potentials, they all add to each other and you get a sustained muscle contraction called tetanus. So this next picture isn't a figure, but I'm going to use it to explain because it's easier to understand with a picture. So during an action potential, calcium channels open from the sarcoplasmic reticulum to the cytosol, as in number 1, and close when the action potential is complete. And then when the concentration of calcium increases in the cytosol, the calcium in the sarcomere binds to troponin, which is in number 2, and then you get a muscle contraction, which is in number 3. Also, when the concentration of calcium increases in the cytosol, the ATP-dependent calcium pumps in the sarcoplasmic reticulum send the calcium back into the sarcoplasmic reticulum, which is in number 4, and then the concentration of calcium in the cytosol returns back down to normal. If enough calcium was moved back into the sarcoplasmic reticulum from the sarcomere, then if you look at number 5, the tropomyosin would cover the myosin binding site on the actin, and the muscle would relax between action potentials. However, when the action potentials are closely spaced together, as in the chart, or as in the last hill on the chart, the concentration of calcium in the cytosol remains high. So calcium continues to bind to troponin, and you continue to have a muscle contraction. To sum it all up, to vary the amount of force our muscles use, our body recruits different or varying amounts of motor units. And in figure 2, when you have a long series of action potentials, you get a sustained muscle contraction called tetanus because there isn't enough time for the calcium uptake in the sarcoplasmic reticulum between action potentials. So calcium in the sarcomere continues to bind to troponin, which is how you get a muscle contraction.